Hello, welcome to Maths with EJD. Still talking about binomial series. In this video, we're talking about common errors and misconceptions under the broad topic of special cases and common pitfalls of binomial series or in binomial series. Now, the first thing I'll be talking about here would be uh, the problem of sign. So you can easily have sign errors when you're dealing with binomial series. Okay. So like we saw the other time, if you expand 1 minus x raised to power n, you can easily forget that minus 1 raised to power k, this factor. So forgetting minus 1 raised to power k factor can actually lead to incorrect signs. It can lead to incorrect signs, can leads to incorrect signs in the expansion. So if you forget about that factor, right, you can easily forget the correct sign. So you have to pay attention to this particular part whenever you have negative sign in the binomial expansion. So forgetting it leads to incorrect signs in the expansion. For example, for example, imagine this incorrect situation where you have that or you have 1 minus x raised to power 3. So you can easily mistake it to be 1 plus 3x, 1 plus 3x plus 3x squared plus x cubed. All right. Whereas the correct thing is actually that 1 minus x raised to power 3 is, so when, of course, generally this is actually summation from what now? From k equals 0 to 3, all right? Then 3 combination k, then you have minus 1 raised to power k, x raised to power k. So easily, right? We already know that 3 combination 0, 1k is 0. 3 combination 0 is 1. Then minus 1 raised to power 0 is also 1. X raised to power 0 is 1. So that first term is automatically, I guess I can even do it in one line. So that would just straight up be 1, okay? Next, 3 combination 3, of course, is 3. But now, 3 combination 1, rather, 3 combination 1, this is for 0. For 3 combination 1, so minus 1 raised power k. You see, the sign now is minus because minus 1 raised power, an odd number, the sign will remain minus. But for 0, it's positive. For odd numbers, 2, 4, 6, and so on, it's positive. So for 1, it's negative. So you can easily mistake this and make it plus, like what you might have here. So 3 combination 1 is 3. All right, we know that. Then minus 1 raised power 1, you have negative, and then x raised power 1. That's why you can now have 3x here. So if you go on to 2, right? 2 combination 2 is also 3. Sorry, let's not worry about the sign first. 3 combination 2 is also 3, right? Then minus 1 raised power 2. That will now be minus 1 times minus 1, that will be plus 1. So that the sign is positive. Then you have x squared. Okay. Then next, you now have to go to the next one. 3 combination 3, that is 1 now. Okay. But you have minus 1 raised to power 3. That can be positive, right? You can see I've even made the mistake already of writing plus. But so now this is going to be minus 1 because it's minus 1 raised to power 3. Then finally x raised to power 3. So this is actually the correct thing, not this. Okay. So you want to pay attention to such signs when you're dealing with binomial expansion for that involves negative sign. Okay. So that is the first situation. You can have sign errors easily if you do not pay attention. All right. So let's go for the next one. What is another possible pitfall you can have? You can misuse. So let's talk about misusing binomial coefficients. Misusing binomial coefficients. So here now, you can easily miscalculate. So miscalculating n combination k, especially for higher values or higher values of n. Okay. So for example, 5 combination 3 is actually 5 factorial divided by 3 factorial, 2 factorial, and that will give us 10. All right. But common common errors include miscalculating factorials. Okay. So, I mean, you could easily do a wrong thing, like you can say 5 combination 3. Maybe because you're in a hurry, you can just say that's 5 factorial by 3 factorial, and you forget that other part, and then this just gives you 20. And this is totally wrong because it's combination you're dealing with. Maybe this would have been correct if you're dealing with permutation, but here it's combination. So you want to pay attention to this so you don't get into that trap. Okay, so let's move on to the third possible pitfall when we deal with binomial series. The third possible pitfall is actually this case where when you're expanding. So expanding negative or fractional powers. These are special situation too. Negative or fractional powers. When you are doing this expansion, you don't want to forget that the expansion is usually finite. So assuming a finite number. So if you assume a finite number of terms, instead assuming a finite number of terms, instead of recognizing the infinite nature of the series when n is not a positive integer. When n is not a positive integer. Okay. So for example, if you have 1 plus x raised to power half, you never want to forget that you cannot have a finite sum. So the best you can have is an approximation. So you may want to now be talking about maybe the first 2 terms, the first 3 terms. For instance, if you need the first 3 terms, say whatever number of terms you have, it is all just an approximation because you cannot have all the possible terms as far as the power is not positive integer. So in this case, now you're just going to have 1 raised to power half, 1 raised to power half, then x raised to power 0 over 0 factorial plus half comes now, then into 1 raised to power half minus 1, that's minus half, into x raised to power 1 all over 1 factorial plus half into minus half into 1 raised to power minus 3 over 2 x raised to power 2, that's x raised to power 2 all over 2 factorial. Don't forget that it continues forever. It doesn't ever stop. So you can just stop here. So 1 raised per half, all the 1, all go to 1 first of all. So x raised per 0 is 1. 0 factorial is also 1. So you have 1 there plus. Here you have half x. Then here you have half minus here, right? So the minus comes. How 2 times 2 times 2 because all of them will be at the bottom at the end of the day. So you have 1 over 8 x squared. Don't forget that it continues forever. So if you don't put the 3 dots, then you're assuming that it has a finite set of terms, but it is not that, but that won't be true, right? So you want to pay attention to that. The same of course applies to the case of 1 plus x raised by minus 1. So for 1 plus x raised by minus 1, right, you simply are going to have 1 raised by minus 1, x raised by 0. Let's say you need the first 3 terms. Okay, let me color code now to at least distinguish that. Okay, so imagine you now have 1 plus x raised by minus 1. So that is 1 raised by minus 1, x raised by 0 over 0 factorial plus minus 1 into 1 raised by minus 1 minus 1, that's minus 2, x raised by 1 over 1 factorial plus minus 1 minus 2 then 1 raised power minus 3, x raised power 2, all over 2 factorial. Again, you don't want to forget that this continues on indefinitely. So don't, of course, and see, I'm already making that mistake. So it's just an approximation. So this is going to be approximately, of course, 1 raised power anything is 1 all the way. So all of that is 1. So x raised power 0 is 0 is 1. 0 factorial is 1 also. So you have 1 here. Then here now you have plus and minus, that's minus x, then over 1 factorial. Then here minus and minus is plus. So you have plus there. Then of course 2 cancels 2 because 2 factorial is also 2, then plus x squared, and that goes on like that. So don't ever forget that when you have the power to be fractional or negative, then you never get all the terms of what you are dealing with. So that's a common pitfall you can get into. So you want to be very conscious of that reality. All right. So that's another situation you should pay attention to. That's error number 3, or pitfall number 3, if you like. So the next one, the fourth one, which I think is going to be the last in this situation, that is domain restrictions. So they are usually domain restrictions for specific situations. So let's see domain restrictions, how that might play out and how you can easily fall for that. So for fractional, so this still applies to fractional or negative power or negative power n. Okay. Expansions are only valid. Expansions are only valid, okay, for absolute value of x less than 1. Okay. So misapplying this, misapplying this can lead to divergent results. So if you forget to if you apply, if the power, I mean, if x is not within this range, you can easily get into some trouble. So misapplying this can lead to divergent results. So if you are using this and you want to probably use it to estimate something, you have to be sure that the value of x, any value of x you're bringing in, actually falls within -1 and 1. So if you forget this, it's going to give you some problem. Okay. So if you applying it outside this range may lead to divergence, just like I've emphasized just now. So that's all for this, talking about the common errors and misconceptions uh, connected to the binomial series expansions. So I have one more to go. There we'll be talking about tricks for quickly calculating binomial coefficients. You definitely don't want to miss that. So pay attention. If you have not subscribed to this channel, be sure to do that right away and hit the notification bell so you can always get alerted each time a new video is released. Then don't comment. Let me know how helpful these videos are for you. And if you see any of the other videos where I've given you practice questions, you also want to show me your answers in the comment section. If you have a problem to solve or a topic you like on the teach, you can just make a comment. Also, let me know. I might just be able to find time to do that. Then like and share so that more people can have access to this great learning. Till I come your way again, keep doing math right. Bye.